Anyway, cool. Awesome to see all of you here. I've got about 20 minutes, and I'm going to talk about building a Node PaaS, although Node isn't, strictly speaking, a requirement, and I won't talk all that much about it, using Docker and CoreOS. So I'll mostly be focusing on those two technologies. So another show of hands, how many of you here have used Docker? All right, more than there are DevOps people, so I presume there's quite a few HelsinkiJS people using Docker as well. And how many of you have used CoreOS? Okay, excellent. Not too many people. That means I can be the authority on the subject, and you will not be able to question anything I say, or doubt it for that matter. How many of you have heard of CoreOS? Awesome, cool. All right, well, let's dive in. So a bit about the context within which I started playing around with this. So the backstory is I only started playing around with Docker and CoreOS about a month and a half ago, right before Christmas. And the reason that I got involved was because I've been building web apps using the mean stack for quite a while, but there are quite a few little things I built that I never got around to hosting. And the reason I never got around to hosting them was because I'm a cheapskate. I didn't want to pay $15 per month for AWS microinstances. I didn't want to pay $10 per month to Heroku. I wanted a Heroku, but I wanted it for free. So I decided to build it. Yeah, and actually, the other reasons were that I basically succumbed to the hype and the buzz. Like, I think that the buzz around Docker had reached the point that Node achieved maybe a couple of years ago, and I just felt I couldn't resist the urge to give it a go, but I needed a real project to sort of check it out, and also give Vagrant a go, which I hadn't really used much either before. All right, yeah, and also I was getting kind of fed up with Amazon. There's a lot of stuff about them kind of cannibalizing their own user base, their own developer base, building services that compete with services that run on top of it. Amazon isn't the simple thing it used to be. It's it's no longer an infrastructure as a service offering. It's much more of a PaaS, and then some. And there's cheaper, nicer alternatives like DigitalOcean that I wanted to give a go. All right, so that's the context. A bit about previous stuff that I've done in this space. So, I've kind of programmed using different environments. I got a bit obsessed with JavaScript, started the meetup here, but actually I've also done some DevOpsy stuff, even though that's not sort of my forte. I guess the first project I should mention is Offshell, which was an IDE and a PaaS rolled in one, and kind of launched as a startup. So we actually built our own custom server using C++, using the V8 JavaScript engine. And that was all good, but what we realized is people actually wanted either the IDE or they wanted the PaaS bit. They didn't really care about the two of them combined. So we kind of folded, but we had a lot of, although it was running kind of as a zombie for a while, we did get a couple of thousand developers signing up to that and using it. And actually, it's in the context of Offshell that I met Solomon Hykes, who at the time was running .cloud, and is the guy who actually created Docker. And then after that, I kind of had an attempt at building Offshell 2.0, for lack of a better term, or a better name. I was basically playing around with the idea of microservices. So I built something that I was intending to open source, but I never did. I used Node.js and the Node Bouncy proxy package. I don't know if anyone's familiar with that. That let you kind of route requests and dynamically spin up new Node processes as a new request came in. And what was different about that sort of platform was that it actively killed processes that were idling. So if a process wasn't processing a request and wasn't using any CPU for a while, it was just like the platform would kill it. Anyway, it was kind of cool, but I realized it was cool, but not actually useful to me. So I never finished it and never open sourced it. But if anyone's interested to talk to me about that, I know microservices are becoming trendy. Happy to chat to you afterwards. Another thing I wrote was something called Bootstrap. This was before the framework came out. That's actually been open sourced. I was going to rename it, but then I was like, whatever. It's a DevOpsy thing, so no one should care. But what that was a essentially, Well, I kind of showed it to some DevOps people I knew, and they basically just laughed at me, and I felt really bad because they did it in public on Twitter. They said that, this isn't the configuration management, so I sort of said, well, it's sort of part of what a configuration management system does, written in Bash. So what Bootstrap did was, it essentially was just a bunch of Bash scripts that, first of all, let you bring up a new AWS instance using their command line tools, and then wait for it to come up and connect to it over SSH. And once it connected, it ran a bunch of commands in sequence to bootstrap that instance. But there was quite a bit of logic sort of thrown in, so you could add variables, you could have like template type of stuff. You could also split up your files into multiple different files, so you kind of had some element of modularity. Basically, it was sort of a primitive version of what Docker files are, right? Which we'll talk about later. Anyway, so that's kind of my history. What I actually needed for this project was, well, since I'm using the mean stack, I wanted to be able to run Node. I didn't really care about other languages or other platforms, but as it turns out, actually adding support for other stuff should be pretty easy once you get Node going. I was using Mongo, and I have been using Mongo as a database, but I've kind of been toying around with Postgres, so I wanted to have the ability to add that at a later stage as well. I wanted to have a command line tool. I wasn't keen on web interfaces, and just do Git push-based deployment. I wanted to support multiple domains. I wanted to be able to run more than one instance of a single process. I wanted to have the ability to limit the resources that any process running on this PaaS gets, both in terms of memory and CPU usage. And actually, I realized most importantly of all, I wanted to be both easy to use, but also easy for me to tweak and extend, right? So, in other words, I wanted something that was more of a toolkit that I could play with and experiment with, rather than a framework where I was kind of constrained by it and had to conform to its sort of standards and best practices. Since this was just for me, I didn't really care about user accounts. If I could SSH into the cluster somehow, that was good. That's all I needed. And eventually, I wanted to have an upgrade path to be able to run this on multiple server instances, right, on multiple virtual machines. It wasn't a requirement to start with, but I thought at some point it would be nice for me to have that ability. Okay. So what are the existing solutions out there? I mean, there's obviously the commercial passes, like there's a whole slew of them. We had the guy from JElastic talk at DevOpsFinland a couple of months ago. There's obviously Heroku, Amazon is doing something as well, and so on. There's a few node-focused passes, like Nodejitsu and others. Right? But to be honest, I haven't been as successful as one would have expected, because it turns out that actually you often want to host a bunch of different sort of things in the cloud. There are some open source passes as well. So one of them that I know at least one company in the audience is using is called Doku. There's also another called Deus, if that's how you pronounce it. Which is actually using Docker and CoreOS under the hood. Docker was just using Bash and Docker. And then there's kind of this whole emerging thing, and I think it's there's going to be a fight and some consolidation in this space. But basically, there's this whole sort of hot space of the data center operating systems, of data center operating systems. And you guys from the DevOps Meetup probably know much more about this than I do. I'm not going to go into too much detail, but we've got things like CoreOS, Project Atomic, which got started a bit later, Mesos or Mesosphere, the company behind it, some stuff from Google. Ubuntu jumped into that space, and then more recently, Docker announced that they're going to be doing that as well, right? And it's not really clear who's going to be the winner, what's better or not. So I wish I could say that I had a very systematic approach to choosing Docker and CoreOS. And in actual fact, I just went with my gut. In fact, at the time I chose this, something went wrong there. At the time I chose this, for example, the Docker orchestration services hadn't even been announced, right? But here's a quick chart comparing like the different features that are kind of relevant. So obviously the commercial passes, are all hard to extend, and they cost. So so that didn't work for me. Then we've got Dace. I actually gave that a go because that was using CoreOS, which I knew had a lot of momentum, but I couldn't get it running the first time I tried it. So I just gave up and thought I can do much better than this. Yeah, and then we've got CoreOS, which kind of sits a bit lower in the stack since it's not a PaaS, but it's a toolkit, but I thought I would kind of list it here. And then we've got other things like Kubernetes, which is less feature complete, and then finally Doku, which actually, well, is using Bash, and I realized I really hate Bash, and I didn't want to be working with Bash anymore, even though I've written some projects using it before. But also, like, it was designed to only run on one virtual machine, right? Which meant that there was no upgrade path to run it on multiple instances in the future. So I chose CoreOS, and the reasons are it has the most momentum, it's well funded, which can go both ways really. You know, MongoDB is well funded, Docker is well funded. You know, what a lot of that funding is funneled into is marketing hype. So one should take you know, a lot of things you hear with a grain of salt, but it means at least they're going to be around for the next couple of years, you know, to fight it out with other guys. You know, they've got a good team. They worked on the service called CloudKick before. I don't know if at least the founders did. Also, it's got Docker baked in, and I wanted to have a play with Docker. It's most feature complete. It's not reinventing the wheel too much. It could run on DigitalOcean. In fact, there was a tutorial for it that could use as a starting point. And yeah, I thought the name was kind of cool. And finally, apparently, I've heard rumor that they give out T-shirts at talks to people that ask smart questions. So there's that. Right. So let's talk about Docker first before we dive into CoreOS and much more detail of how the PaaS as a whole works. So I pulled some of this stuff out of Wikipedia and other stuff just out of random comments somewhere on the internet from about a year or two ago. But the Wikipedia, I guess, explanation for what Docker is, and I'm specifically using the term Docker engine because Docker is the name of the company. There's Docker Hub, which is the place where you store your images, and then there's Docker Engine, which is actually the tool that runs, you know, your containers and whatnot on the servers, right? So Docker Engine is an application runtime and packaging tool, and it allows independent containers to run within a single Linux instance, avoiding the overhead of starting virtual machines. And that was clearly one of the things that I noticed when using Bootstrap. So with Bootstrap, you would bootstrap an AWS instance, so it would take you like 2 minutes or maybe a minute for the VM to come up, and then since you had to bootstrap it from scratch, it would take another 5 to 10 minutes for all the Ubuntu packages and whatnot to be installed. Right? With Docker, you don't have that overhead of having to bootstrap a whole VM, so you can start in less than a second. And then in addition to that, there's some features which mean that when you're doing development, for example, you don't need to rerun all the commands from the very beginning. But more on that later. A kind of a negative comment on Docker that I picked up a while back is, which I kind of sort of agree on with, is that it's a user space tool built on top of Linux containers, right? All the hard stuff is actually at the lower level. Okay, it happened again. All right, so basically all the hard stuff is being done by other guys that have been at it for a while, and Docker just kind of, came on the scene with a bunch of funding. He started giving out T-shirts and stickers and stuff. Got everyone's attention. Oh, it used Go as well, which is the next cool thing after Node, apparently. Actually, CoreOS uses it too, so I think there's room for a Go meetup. But anyway, that's a separate story. Anyway, and yeah, they didn't really invent anything particularly new. They just packaged up existing technologies, and that, I still sort of have that feeling. Even though now they're actually not using Linux containers, they've kind of written their own thing. So in the future, it should, in theory, be able to run on Windows. But anyway, still, there's a lot of hype. So here's a little diagram that I pulled from this source, which kind of shows the difference between a VM and a virtual machine, like say Zen or whatever, or a virtual box and Docker. So the difference is, if you're running a VM, you basically are duplicating all the functionality of the operating system, because it runs a separate operating system for each sort of virtual machine that you're running, right? There's a separate guest OS. Docker is or Linux containers are much more lightweight. So you're able to essentially skip the bit of running the OS. And in fact, the Docker philosophy is that you're sort of only supposed to run one process inside a Docker container, but not really. You can kind of escape that and run more than one process. But it's much more lightweight. There's less isolation between the containers. So from a security point of view, you know, even though Docker is able to constrain the resource usage of anyone, and in theory, it shouldn't allow you to escape to the host OS. In practice, it's still possible, from what I hear. But actually, the way in which Docker seems to be deployed in practice is that we've taken this simple model and merged it with that more complex model on the left. And in actual fact, you've got you know, a host OS running multiple guest OSs, which in turn are running the Docker engine, which in turn is running containers. So it's like this sort of Russian doll. And inside each of those, you've probably got an extra JavaScript VM and so on. So and then the process repeats over again, you know, ad infinitum. But anyway, that's how things are typically deployed. So I don't know where we're missing half of that last line, but never mind. So the Docker engine, essentially, what does it offer over Linux containers? So it's portable deployment across machines. You know, so basically, it takes care of things like network configuration, so like mapping ports from the container to the host OS, mounting volumes, you know, resource management, etc. So it's application not container centric, like I already said. So it basically kind of watches one process, and the Docker container stops, you know, or is killed when that main process stops, even though there might be other processes running within as well. And this means that anything you run inside Docker needs to be Dockerized. So if you have like upstart scripts, something where you type, you know, start nginx, and then control is returned to you, and some nginx daemon is kicked off in the process. With Docker, the sort of philosophy is that since you only have one process, it should print out its log to standard output. So there's a fair bit of work that you need to do to convert, you know, like an application using nginx or some existing Ubuntu package, for example, to run using Docker, which I find a bit strange since all that effort's gone into making all those upstart scripts. You're kind of going back and tearing all that down again. But never mind. Yeah, and then finally, you've got the build tool, which lets you build you know, build your images, which you can then use to start up the containers. And the cool thing is that it's using so-called layered file system. There's a picture on the next slide that I'll show you. But it means that basically your file system is cached at every level. So if you make a change to your server configuration, you know, in a Docker file, it'll only go and make the changes from that line onwards and rerun only those commands, and all the previous commands will be cached. Right, and finally, and this is something that I'm kind of on the fence about, but basically you can build obviously the images locally, but the idea is that they kind of want to be, Docker have stated that they want to be the GitHub for running applications. So, you know, they also have Docker Hub, right? So the creative name that, but anyway, it lets you push and pull images, you know, and you pay them if you want to have, you know, private repo and your own private images. And they've gone beyond just having a hub, which we'll talk about later. But what does the Docker command line look like? So there's not time in the 20 minutes to go through all the commands real quick, you know, but real quick. But I'll just kind of mention the main ones. So first, you pull an image, like a base image, like Ubuntu. Then you actually run it. There's a few commands to list all the running containers, because there's a daemon, Docker daemon running in the background, you know, keeping track of all the containers. You're able to view the logs from any given container. You can stop them, and then you can actually sort of commit changes to your image. And also, that's kind of the interactive way of building a Docker image. But alternatively, you can build a Docker image from a Docker file. And finally, you can push that Docker file, assuming you have an account and all that set up on Docker Hub, back to you know, Docker servers. Or, you know, you can omit the push step and just use it locally, which is what I opted for. And so this is kind of a picture that describes how the file system works. So you basically have your kernel at the bottom, and then with every image that you add, it's kind of like a layer on top of that file system. So you can basically have a hierarchy of images built one on top of another, and every layer above references one of the images below it, right? In fact, every single command that you run ends up creating a separate image. And since you don't want to do it interactively, you actually want to commit your sort of server configuration to Git or something like that. The way you do it is in Docker files. So here you specify that you're extending the base image, which you've pulled, and then you run just standard Linux commands, much like the stuff I did with Bootstrap. So you run apt-get install whatever the heck you want, set up some links, and so on. Each of those ends up adding a layer to the layer of the file system, right? And then there's some other extra things thrown in, like you can mount external data volumes, specify the working directory, and also specify in the main command which this container runs if you omit sort of an entry point. Okay, so then we move on to CoreOS. So CoreOS, again pulled from Wikipedia, is a lightweight OS providing infrastructure to cluster deployments. So it's a fork of Chrome OS, the one in Chromebooks, and includes no package manager. Basically, pretty much the only thing it includes is a couple of its own tools called etcd and Fleet, and the Docker daemon, and then command line tools. So what etcd does, it provides essentially shared configuration in a cluster, which you can access either using a REST API or the command line tool. And then Fleet provides the daemon for cluster management, which is actually under the hood using etcd to figure out which process is running on which server, what's the load on any given server, and essentially uses various rules to start a new process on a server in the cluster. So etcd is pretty straightforward. It's just a key value store, so we're able to set, retrieve values, list values in a directory, and remove either individual keys or whole directories. Fleet is quite a bit more complicated. There's basically a bunch of commands such as submit, load, start, stop. I still have trouble figuring out what the difference between load and start and stop is, but the long and the short of it is you've got unit files which describe your essentially a single service in your application. So for example, you might have one for MongoDB, another one for Nginx, your load balancer, and then you may have one for your Node application, as is the case here. So first, you load them from the file system into the cluster. You do that using submit. When you call load on one of those files, that actually loads them into the cluster but doesn't start running it. Start loads it and starts it, or starts it if it's already loaded. Stop does what it says, it stops it but doesn't unload it. Journal gives you the logs. Under the hood, each service can basically be any process, but typically it's actually a Docker container running it, so you can get at the Docker logs through Journal. Then what destroy does, it stops if a service isn't running, and it actually removes it from the cluster completely, so you can resubmit a new version of the same service file, a unit file if you want. And then you're able to list units, which are the actual running services, or you can list the unit files. And there's a difference because, well, first of all, not all the unit files are necessarily running. And also, you have this ability to have templates. So you can have, if you have an @ sign in your service name definition, it means that what you're actually doing is loading a template, and then you can have multiple instances of a service using that template, and you can pass arguments to that template by adding extra stuff after the @ sign. This is what a simple unit file looks like. So basically, there's just some textual description. It says that it requires on another service in order for it to be able to run. So that service needs to be present on that host. Yeah, and it should start after a Docker container. There's a bunch of other stuff where you can have like an xconflict section and say, don't run this on other servers that are running the same service. But the kind of the core of it is this exec start command where you specify, okay, this is where I want to run my Docker container. And if you're using a template, then the stuff after that sign gets passed to you by this %i command. There's also some environment variables that get passed in, like the private IP of that particular instance. Okay, so anyway, intro out of the way, we get to the meat of it. Even though I was trying to get other people off stage because their time is out, I'm running out of time myself, but never mind. This is all that I wanted to build, right? I wanted to have Nginx an Nginx load balancer. I opted to use that instead of Node itself because, well, if there's a bug in Node or a security hole, it's actually more likely that Nginx will get patched up first, and actually Nginx, provides you all the configuration and stuff. You don't need to write your own code for that. Then I wanted to have, however many app services for the different applications that I want to run on top of this platform, and I wanted to have the ability to have them some of them only run one process, others maybe two instances of the same, two processes for the same application. And finally, MongoDB database, behind all of them. So I wrote opshell, and this is how you use it. You install it, or you will be able to install it once I publish it, with npm install -g opshell. Don't take that name, by the way. I haven't actually taken it for myself yet. And don't try sell it to me after this event, after this talk. Anyway, so what you do is you can then create an app just like with Heroku using appshell create hello, where that's the app name. You can set environment variables. You can add new hosts, so like domains, which that app serves. You can call offshell deploy, which under the hood just does a git push. You can scale it. You can view the logs, and you can finally destroy your application. Okay, so it's as easy as I could make it. I doubt this could be more simpler. Unless you had auto scaling and so on, but that's actually something I want to have control over. Anyway, how does it work under the hood? So first of all, like I said, I realized as I was writing this, because I started writing this as a bunch of bash scripts, I wrote it as scripts that I kind of rsync to the server, and then I realized I don't like bash. So I wrote something that lets me basically use JS to drive an SSH session on the server. Right, so nothing ever gets copied on this. No code as such gets copied to any CoreOS instance. I just connect over SSH, and then in JavaScript call different commands. Right, and I can do things like put files, temporary files on the server that cleaned up after the session is over, and so on. So what opshell does is it writes the local configuration. So it asks you for what's the actual IP address or the host name of the CoreOS server and the cluster that you want to connect to. It sets up the SSH connection, saves that in the file system. Then it builds the Docker images using the Docker build command, like I showed earlier. It creates a sample opshell app, so instantly you can start connect to the platform using HTTP, and you'll get something back. And then it calls submit on all the fleet control unit files, and then it starts up Nginx, MongoDB, as well as some other services that do things like MongoDB backups. So there's the ability to have timers that are like cron jobs that run in the cluster, so you can schedule stuff to run once a day or whatever. So what opshell create does, it sets up a Git repo. It creates a directory where the actual code of the application gets copied over to. When you do a git push, it adds a default host and other entries to etcd. And then it adds a remote to your local Git repository if there is one, and then it calls opshell scale 1. So it basically spins up one process. So again, if you've typed opshell create app name, then you can instantly see that something is running up there, even though it's not your actual application. But then you can just type opshell deploy, and that'll deploy the code. So opshell env and hosts are quite simple. All they do is they just add entries to this distributed key value store. And there's a cool thing whereby there's an etcd daemon running alongside Nginx. So basically, every time any of the values in the key value store are updated, confd creates a new configuration, checks if it's different from the existing configuration, and if so, restarts Nginx. So basically, that's how the new routes are added. That's how the load balancer knows that there's multiple processes on different ports on different hosts to route the traffic to, and so on. So what opshell does is just a git push, and it's the hook that does all the work on the server, and that's been created when we call opshell create. So what it does is it checks it out into the directory, it calls npm install, updates dependencies if needed, and then it restarts the process, with essentially something like this in a loop, so that when this crashes, you can restart it again. I opted not to use something like node-mon or supervisor because I know that the files aren't going to change. I only want to restart the process with a bit of a delay if it exits. So opshell scale, logs, and destroy. Essentially, just use fleet control under the hood to start and stop new units. And depending on whether the current number of running units is greater or less. There is no like configuration state stored anywhere in the cluster other than in etcd. So I use that information. Opshell logs just use fleet control journal. You can also tail them if you want. And finally, destroy. All that does is scales back down to 0 and then removes all references to your app from the file system, like the Git repo and the data directory. So I ran into a few gotchas, which I'll run through real quick. So the first one is dangling Docker images and old containers. So as you work with Docker, by default, it just kind of keeps all the old stuff that you've ever created, and your file system usage kind of goes up. So there's a few things you can do. You can have it automatically clean up after you call run, or you can call a command that'll clean them up for you. But it took me a while to notice that. Another thing that was a bit odd was that all the fleet control calls are asynchronous. So like when you, for example, start a new unit, you expect it to only return control to you once it's actually started. But it may take from anywhere from 1 to 5 seconds for a new service to start up. So that kind of caught me off guard a little bit. And in general, I think that the fleet control kind of command line tool design is a little bit strange, where there's some magic happening under the hood, and there's kind of this discrepancy between destroying and submitting stuff to the cluster. Escaping special characters is a real pain in the unit files, especially since essentially the logic in your unit files, often you need to pass stuff into the Docker container, and that needs to run within the context of the CoreOS host and not the actual Docker container itself. So you basically end up having pretty bloated unit files. That's something that I wasn't too happy about. It took me like 6 hours to debug this issue with escaping of a $, because apparently, etcd or convd rather kind of treats $ plus curly bracket differently from just $, but never mind. The documentation for how Go templates work, which are then used to create the Nginx configuration for the load balancer from the settings in etcd, is pretty bad as well. So that kind of bit me. And finally, another thing, which is a feature, but again caught me off guard, is that CoreOS updates itself automatically. And when it does, not all your services come back up necessarily, or the order in which they come back up can be a little bit unexpected. So I'm still working to fix that issue, but all the other issues I've resolved. So in the future, I'd like to publish it. So hopefully it'll happen tomorrow. And then so you can check it out at opshell.net, which will just be a redirect to the GitHub repo. And then fix issues with updates, add support for SSL, which is pretty easy. And I guess the main thing that's missing is actually clustering. So at the moment, Opshell only runs in a single VM and a single host, but it shouldn't be too difficult to add NFS support and have like a shared drive that all the instances share. If one does that, though, one starts to ask, well, then what's the point of having etcd in the mix? Because essentially NFS could be used for the same purpose, but never mind. And then at some point down the road, I'd like to add monitoring as well. I think the future of kind of CoreOS and Docker is very much unclear at this point, given that basically both companies are competing for the same space. There's been quite a bit of drama, towards the end of last year, because basically CoreOS announced Rocket, which is competing with the Docker runtime, because they're saying that the way Docker have gone about creating their container standards is crap, whereas Docker in turn have created their orchestration services, which are doing exactly what CoreOS is doing. Yet they're all saying that, even though you guys suck, we'll still be able to all work together and interoperate with one another. So, a year later, I'm gonna have to rewrite this in some third thing, which tries to abstract both of them away, but we'll see how that pans out. Anyway, here's some links. I'll post these slides that you can check out if you want to give this a go yourself. And obviously, if you want to try Opshell tomorrow, you'll be able to go to opshell.net and see the source for yourself and take it for a spin. Thank you very much. Sorry for running over time.